I'm the lead software for Team 21364 First Try, and today I'm going to be talking to you about how to use like finite state machines for automation in both TeleOp and Autonomous. All right, so what is a finite state machine? A finite state machine, or an FSM, is a programming model where a system can only be in one defined state at a time and transitions between states based on inputs or conditions. So think of this as like a set of containers. Your robot can only be in one bucket at a time, and each bucket can kind of handle situations differently. Oh, my fault. Now, you would use this for its single state capabilities. So since the robot can only be at one state, it can like reduce conflicts in code and simplify the readability of it. Each state can also have its own set of behaviors, allowing the robot to better adapt to changing field conditions. So you can use this to set up defined like intake and delivery modes and have the robot behave differently in each mode. And using an FSM makes programming sequencing based on sensor input both easy and readable. So FSMs really get rid of like the 10 generation line of if statements that you would have to do otherwise to set up complex automations. So it keeps code clean and readable. It's easy to debug because it's only in a single state at once. So there's only one point of failure at a given time. And it's also scalable. You can keep adding states to meet whatever behaviors you want to. So the best way to define your states is to use what's called an enum or enumerator. This allows you to like name your states instead of just using integers as your states. So as you can see, we have an idle state, an intake state, a shooting state, and a driving state. And each one of those could have their own specific set of behaviors and actions that it can do only in its designated state. So to switch between states, we need a switch statement. It's set up like this, and there's different cases to a switch statement. So in idle mode, if gamepad 1.a is pressed, then the current state will switch to intake. That line of code only runs if you're in intake, or if you're in idle mode. Sorry. So I think you can see the power of a switch statement. One way you can use this kind of statement is by reconfiguring your controller. So if you have, let's say, an action button, so you want to use A for your action button to control all of your actions throughout your entire teleop. You can use states that reprogram what A does at certain times. So if you're in idle mode, A will switch to intake mode. And if you're in intake mode, let's say it's at A, and you hit it again, that'll transition you to shoot mode. So that's a different behavior between idle and intake mode that that same button can do. Now you can use finite state machines in TeleOp, Autonomous, and to control subsystems. In TeleOp, you can control your entire game loop by using sensor inputs to influence how the robot behaves during the match, creating like a much more readable, cleaner code structure and a smoother driving experience. In Autonomous, you can use an FSM for sequencing like you would in TeleOp, but instead of going off of like button presses, you can go off of end states and sensor inputs. This is how like the Pedro Pathing library works, a switching state machine. You can also put state machines inside of state machines to control subsystems. So if you need to move like a complex jointed arm in your delivery mode, you can have a finite state machine within the delivery case to drive that arm and use timers and stuff like that to switch between states. So when you're setting up your finite state machine, you want to use intuitive names such as like normal state, intake state, or delivery state. This keeps the code very clean, very readable, very concise. You should start small with just a few states, only the ones necessary, and then you can expand out as your systems grow. For debugging during testing, be sure to like display the robot state through telemetry to avoid confusion. This also helps you like pinpoint where a failure is, since you can only be in one state at once. So that was my presentation. I have much more detailed instructions on my website, firsttryrobotics.com. There you can also email me if you have any more in-depth questions that weren't answered there or here. But that is what I have for you on finite state machines. Feel free to ask any questions you have.